Great. So let's begin with our talk with Vatsal Shah from script to solvers. Okay?
Hey, good afternoon, everyone. That's a very slow start after lunch. Expected. So my name is Vatsal, and I'm a principal solutions architect with AWS. Today, I'm here to talk about scripts to solvers. I started when I started my career. I started it with Python as my primary language. How many of you started your careers as Python? Wow. Okay. So just to put things in perspective, I started in 20, 2008 and I graduated in 2013. That time, not a lot of you would have raised your hands. It was a niche language. I was trying to create a mode for myself. Most people were doing Java, C++. Again, very commoditized at that point in time, right? I had to thinking selfishly about myself, I started with Python. And I found a college which offered Python as their primary language. Wasn't very common back then. Now I think it's the most common language used in most colleges. But hey, we are here to talk about agentic AI. And why I mentioned that example is because I personally felt that Python was also being commoditized in the recent years. It didn't really matter which language you used. Uh, Rust, Go, a lot of newer languages came into picture. But I think it's changing again, right? And it's changing with the advent of Gen AI and agentic AI. And you would have been privy to most popular frameworks are today written in Python, right? Node.js is catching up, but I think there's still a long way to go. And let's talk about agentic AI because the session is about agentic AI. How many of you think agentic AI, or let's call it agents, is a new concept? So all of you feel it's not a new concept, is it? Okay, good. So I believe as well that agents have been there for a long, long time since the advent of automation, and we used to call them scripts back in the days. Now the buzzword is agentic AI. It's essentially, if you look at a script, you're trying to automate something, right? And it can be anything from your CI/CD jobs to actual something to do with reporting, products. It can be any of those. But how are scripts different? And with the advent of agentic AI, how do you kind of start rethinking the process of writing a script? Rethink how do you write an agent and not a script, right? So that's the focus of my session. So let me start off by just identifying. Let's identify the challenges that are part of the script, right? Or a classical agent design. If I have to call scripts as agent, what was the classical agent design? So in the past, we relied heavily on manually coded state machines. So if you look at the workflow that we used to write in a script, they were all very manually coded, right? And they were rigid. It will be a bunch of if conditions to simplify things, right? And then you will have some error edge cases. You'll have try and catch conditions and so forth. So what and if you look at it and think about it retrospectively, right? Those systems were very brittle. Day in and day out, your scripts fail. They can fail because you missed on an edge condition, or they can fail because the input or out the input mechanisms have changed, right? So some of the things there were a lot of variables when you talk about them. So and then it's as a developer, it's like super difficult to cater to every possible edge scenario, right? It's just not realistic. And then that's where the maintenance part of it comes in. And think about this, that you are handing over the script to somebody else, and if it's like a long script, the understanding of the second developer might differ. They might not know what all you thought about when you wrote that script, right? So there are obvious issues with scripting or the traditional way of scripting, right? Which is what I call it a classical agent. So if you have to rethink this and think about model driven agents, I'm calling agentic AI as model driven agents because that's essentially what it is, right? So what's different about the model driven approach? So instead of trying to predict everything and code every step of your way with exceptions and everything else in place, what we are saying is let large language models or LLMs be the brain of it and let them drive the agent driven behavior, right? Now, this is only possible because these models now have the capabilities of deeply reasoning with itself, right? And the result of this approach is going to be the agents are more flexible, they will become more resilient, and they are easily be able to they can easily adapt to the new conditions or changing conditions, and hence the outcome of that is easy maintainability, right? So just to give you an example, a real example, a production level example, at AWS, we built a lot of production AI agents. So a lot of you must have heard of Kiro. Kiro is our IDE, right? Which is based on spec-driven development, and we'll talk about a little bit about that as well towards the end. But projects like Kiro, Amazon Q, Glue, and so forth. We are expanding that portfolio to a large extent. What we found is that traditional orchestration was very hard, and it was kind of holding the models back, right? If we were creating like strict workflows that if somebody asks this, you have to follow step 1, 2, 3, 4. It was a limiting factor for us. So that's where we thought that the LLMs have become more clever, and they are not, it's counterproductive to put them in a rigid framework. So by giving these models more control, we saw them that they were able to function better, handle tricky workflows that were not possible earlier, and they were also able to handle the edge cases pretty well, taking away from the whole brittle model that we talked about, right? Which is essentially hand coded logic. Now, what is the outcome of this, right? This helped us prototype most of the newer features 10x faster. And this is a real metric that we track as a KPI at AWS. So, and 10 times faster, and also being able to absorb newer features and edge cases much better in terms of the bugs that were being opened, the issues or feature requests that were coming in, they also kind of slowed down because we were able to have much more open-ended flows. Now that, and hence developers can kind of get more powerful in terms of customization and write simpler APIs, right? And that kind of is a game changer for us, right? Suddenly edge cases aren't scary anymore, or they're just handled by the models. You need to rely on the model to kind of take care of the edge cases. And this is why I'm mentioning all of this is as a developer and coming from a traditional scripting agent mindset, this I've seen most developers struggle with this approach, right? To give away control. And I'm not saying that we should not have human in the loop, and that's something that we should all have, but you should not have strict checks. You should not have hard or hand coded logic. Let the agent do most of the reasoning and fixing self healing part of it, right? Okay. So one of the most important things to get to this agent-driven development or agentic AI, rethink in the way that you are able to leave the control to an agent. I call it the agent loop, right? Where intelligence kind of meets action. And at the heart of these agents is something which is the React paradigm, right? What is a React paradigm? So think of agent asking itself all the time. And that's why I'm able to leave control. What am I trying to achieve? This is the first question your agent should be asking itself. What information do I need for my use case to be complete or my instruction to be complete? And what tools do I have access to, right? So these are three core things that fit into the React paradigm so that the agent is able to think for itself. Now, instead, like I said, instead of scripting every action, we should we should focus on precision context. Now, what I mean by precision context is give the agent the right system prompt, spell out which tools it can use. Now, it can have access to a wide variety of tools, not just local, but also via MCP servers. A lot of you might have heard MCP servers in other sessions. I'm not going to cover too much into it, but if you have discovery of tools, what all can it use as an agent is important. And then finally, include relevant context history, right? So if you have a multi-agent collaboration, how much of that memory can I use across agents? That is also important. And we'll talk about these things in more detail when we talk about productionalizing this, because this becomes even more important when you think about taking that experiment that you have to production. And this context kind of shapes its decision making, right? Allowing it to nudge or limit behaviors without hard coding a bunch of rules that you might have hard coded if you had taken the classical approach. Now, scaling patterns, I feel, while designing an agent, you have to rethink most of the engineering that you have learned in scripting. And why rethink it is because there are four major scaling patterns that I see, or architectures that I see with when you're designing an agent, right? And all of this is not using an agent. Usage of an agent is very different from writing your own agent. As a developer, now the next level, the next skill that we are all learning, and you should be learning if you're not, is designing how these agents work. How do you write an agent, right? So for you to be able to write an effective agent, you need to understand four scaling patterns which are important. Now, the first scaling pattern is agents as tools, right? Essentially your hierarchies. Now, to understand this better, let's think of an example. So imagine if you have an executive assistant, right? You have an EA, and so the EA agent is probably not able to handle travel planning, and I'm traveling, so I want to travel from point A to B, and I've asked my EA agent that, hey, can you help me with this travel? So this EA agent is not capable enough to do anything itself, but it's reliant on a research agent, for example, or a travel booking agent, where it just hands off, and then the travel booking agent will do the travel planning, execute it, and give it back to the agent, to the exec assistant, right? So that's essentially thinking of agents as tools. So I'm just handing you over for a task, and then I'm taking the outcome back. That's the most simplest thing, or the simplest pattern that we see. Now, second is swarms, right? Now, essentially, swarms are where agents collaborate as a team, and we are moving more in terms of moving towards more advanced techniques. You will see how I kind of go through that towards meta agents, but let's talk about smart swarms for a second. So now let's go back to that example and think about if you were to write that research agent, right? What is a swarm? While researching, you might have to rely on multiple agents or tools. So, for example, you might need to do a web search. You might have to rely on booking websites. You might have to rely on airline agents. So, all these agents are thinking themselves, taking their own decisions, and coming back to the EA agent, right? So, if you were writing this research agent, then Swarm is essentially autonomous collaboration. Now, the next level is graphs. For you might have use cases which are very difficult to abstract out in terms of you need like rigid workflows wherein an audit agent, right? So in terms of, let's say, in scenarios where you need strict sequence, where your multiple agents are working, sharing context, but the handoff to subtasks is very systematic. You cannot deviate from that system, which is like an audit system, right? So that's where you need graphs or structured workflows. So that's another pattern that is important. Now the final pattern, which is meta agents, right? Essentially what meta agents mean is that can spin up teams on the fly. So think of agents being able to create agents and tools on the fly. And that's, I think, the most advanced technique, self-healing technique, evolution technique that we are seeing as we progress in this particular landscape, right? So this capability lets the agents adapt in real time, spawning sub-agents to handle the work, right? Now, as much as we want to build these agents, I think it's also very important to understand what are the frameworks and tools available to us. So and I think the most powerful thing today is the ability and the open source world that we have access to. And that's what I mentioned in the beginning. I think Python is a language of choice for most popular frameworks to build on, right? Most of these frameworks, while some of them also support Node.js, Python is the primary language. And I think all of us are lucky enough, some of us might also be contributing to them. But I think it's important while you build those agents, and we'll talk about that as well, to choose the right framework for you, right? And we've also, I think, on the extreme right, you would have seen Strands agent. Strands agent is a byproduct of Amazon Q, Kiro, all the agents that we are building at Amazon. What we did is we abstracted out the underlying framework in terms of all the capabilities and exposed it as an open source project. Something very similar to what we did when we started AWS, how we forked out of Amazon, took away all the heavy lifting of infrastructure management. Similarly, while building an agent, understanding how agents run at production scale, uh, take took that and then exposed it to all of you, in enable like you to be able to contribute and also utilize these frameworks, right? So no matter what framework you choose, just understand it should support the patterns that we spoke about, and it should be as easy as building those and ensuring that you have the capabilities of observability, security, all of those things, especially when you're moving to production, right? So just to give you a quick example, if you had to write the swarm architecture or implement the swarm architecture in Strands, it's as simple as this, right? You have three different agents, and you can just put it behind an abstract class, which is swarm, and it will create a completely autonomous architecture, which is each agent can take their own decisions and come back to the core or the main process. Now, uh, to make your agent successful, and this is what I mean by making your agent successful, you would have, I don't know if you have seen the study that was done, 40% of all Gen AI, Agentic AI projects fail. And typically, where I see it, they fail because they've not been thought through, either from a business standpoint, or they've not been thought through how will this operate in production, right? We are all used to picking the largest LLM out there, but does that sustain? The answer is no. If you really have to understand what task is apt for which LLM, right? If you pick the biggest and the greatest LLM for trivial tasks, wherein, let's say, you would have heard some news about, people saying hi and how companies were burning money by just replying to that hi, right? So such scenarios, which has a simple NLP answer, should not even go to an LLM. Now, similarly, only complex reasoning tasks should go to the larger LLMs. Smaller LLMs should be able to handle the simpler task, right? So and so forth. So think about those things. What are your models? What are the model capabilities? Implement that smart routing logic so that you are routing the right queries to the right LLM. And then obviously all of this is only possible with the right framework of choice. While as AWS, we support almost every framework that you saw in the last slide and more in terms of ragas and other frameworks as well in terms of particular functionalities. But again, now thinking about production, right? How do you productionalize all this? When you talk about productionalizing all this, you have to again think about how you think about your microservices. You have to think about how do you run and operate these agents at scale. How do you provide the right isolation layer? How do you provide identity and management layer? How do you give the scaling layer, right? All of that comes into picture. And one more thing that comes into picture is interoperability, right? Which is essentially start thinking of how are people going to use your agent, or how are you using other agents? How are you making it more modular, right? Similar concepts to microservices. You expose APIs. In the agentic world, you have to expose your agent or utilize other agents via MCP or A2A, right? So you have to actively think about these things to be able to be successful in production. Now, like I started my session with, if you want to utilize these agents, you are in the right language of choice. Most of you raised your hands when I asked you if Python is the right language for you. What I've given that QR code for is how do you implement with all the frameworks that I showed you? How do you implement your use cases with that? And that's where may the force be with you. I think the trend is again picking up with Python to get that moat even in your professional career and even from your prospects. Uh, so I think right place, right time. Again, it seldom happens that the commoditization kind of reverses back, and I think that's happening. Now, how do you get started with agentic AI? Right? I spoke about a lot of things, but if you had to start now, there are two major areas where you can start. Right? Which is first is how do you use agents, and the second is how do you build agents. In terms of using the agents, you would have all seen since last 2 years, we all started with auto completion. Then we slowly moved in terms of copy pasting from a chat agent, and now we are in a completely autonomous mode where you do a lot of vibe coding, and we are moving towards something which is spec driven development. How did this come into effect, right? The promise of an agentic development was complete autonomy, true collaboration across teams, and high quality of code in production, right? So, in terms of challenges, and if you would have used any of the tools that are available in the market in terms of AI development, you would have seen scaling challenges, limited control, spaghetti code, code that you can't even understand, right? So, you need to actively now think about if you had to use AI driven development in production, you need to start rethinking your SDLC process. You can also search once the session is over, which is called AI DLC, which is all about spec driven development. How do you make your vibe coding more deterministic? How do you use AI driven development in your existing brownfield projects, and at the same time be in control of what's happening in an agent, right? On the other side, while building an agent, these are the important things that you have to keep in mind: identity, security, discovery of your MCP servers tools, and you should always be able to audit and trace back any issues that happen, right? And to aid in this aspect, you have something called Agent Core, which is part of the Bedrock ecosystem, which helps you deploy your agents. Any of the frameworks you might be using, Crew AI, LangGraph, LangChain, or Strands, you have one-click deployment into Agent Core, which is essentially something like this. If you had to implement an entire workflow end to end. And if you want to know more about this, please stop by at our booth. We have a booth outside where we can cover this in much more detail: Agent Core, Bedrock, all of these components. But these are the components that really help you productionalize your agents, right? Now, very quickly, if you have to build a customer support system where I have 4 different agents, right? A typical way of building this would be something like this, right? Where I'm connecting all these different components. This is a traditional way of building an agent. But if I had to reimagine this in an agent core world where I have lambdas isolating my compute layer runtimes and giving me identity access management as a first class citizen, tracing, all of those things, it's as simple as this, right? A lot of blocks kind of disappear. And that's the power of agent core. And to interact with Agent Core, we have Python SDK. We have written an Agent Core SDK, which you can use. Again, very simple to use. It also has a command line module to it. And then you also have a starter toolkit which can create blueprints. You can use that blueprint to use agent core within the same frameworks. You don't need to rewrite your applications if you're writing in lang graph or strands or any of the crew AI other applications as well, right? And you should be able to see all of those things on the console as well in terms of runtimes. What are the running agents? If the agent failed, how do you go back, audit that? All of those things are easily accessible via the console, plus obviously the CLI and the APIs that you have access to. You also have Boto 3 access. If you are using Boto 3 in your automation scripts, you can use Boto 3 to control agent core. There is control plane and there is data plane. So there are two separate clients for that. And yeah, these are the two important resources if you want to build with Agent Core, Bedrock. This really helps. The what these examples have is end-to-end use cases. May it be developing an SRE agent, or may it be developing a text to SQL agent, or a BI kind of agent, right? With text to SQL. So a lot of examples are part of it. You can actually use these samples as starter kit for your projects, and this will really accelerate, because 60-70% of the work is done, and all the use cases there are all production grade. So you can very easily take that, get inspired, and then build your agents, right? So it serves as a good starting template. And that brings me to the end of the session. Thank you so much, guys. Again, may the force be with you. I think you're in the right time, right place, and hopefully you'll utilize a lot of the things that I spoke about. Thank you.